Hey all, today we're going to start talking about transformations in the coordinate plane, and we're going to start with reflections. And in order to talk about reflections, we're going to talk quickly about symmetry. So sometimes shapes have lines of symmetry, and a line of symmetry is basically a line that you could fold the shape over uh, directly onto itself. So this line here that goes through this triangle, if I were to fold the triangle right on that line, each point on this left side would fold directly over onto a point on the right side. It would be right on top of itself. Same thing would happen with this star. If I folded the star over that line, every point on the left side would fold over directly onto a point on the right side. Sometimes shapes have more than one line of symmetry, and in fact, this star would have several lines of symmetry. We can do the same thing here. We could fold it over that line. We could fold it over that line, and so on and so forth. The heart, same thing. If I fold the heart over this line of symmetry, it would fold directly onto itself. It's sort of like a mirrored reflection. So if this part of the heart was sort of looking into the mirror, it would see this part. So when talking about reflections, we talk about symmetry because reflections really create a symmetric picture. So if I want to reflect a point or a group of points or maybe a shape over my x-axis, remember x is the one that goes horizontal, this axis is sort of like a line of reflection. It's like a mirror. If point Q was looking into the mirror, it would see itself on the other side of the mirror the same distance away. It wouldn't look like it was closer. It wouldn't look like it was further away. It would look like it was the same distance away. So I can reflect this point over this line of reflection by counting the number of units till I get to the line of reflection. 1, 2. And so that means the reflected point is going to be 2 units, 1, 2, on the other side. And we tend to give that a name, Q prime. So we name it using the same letter. We put that prime next to it because it's an image of what we started with. And you can see that they're the same distance away. It looks like if I were to fold this coordinate plane over the x-axis, Q would land right on top of Q prime. If I want to fold over the y-axis or reflect over the y-axis, that's this vertical line, we do the same thing. I count how many spaces till I get to the y-axis. 1, 2, 3. And so my new point is going to be 1, 2, 3 units away. And I'll call this one Q double prime because I already have a Q prime on my picture. So if I were to reflect a point more than once, I'd want to give it another prime. It's really just like an apostrophe right there. And again, it looks like if I were to fold this over this y-axis, Q would land right on top of Q double prime. And I plan to do the same thing here, but let's move on. Sometimes we're not just going to reflect across the x or the y-axis, we're actually going to reflect across a line. And so it's important to remember that horizontal lines in the coordinate plane have the form y equals and then a number. And that number is how high above or below the x-axis is it. And so if I start at the origin and I count up 1, this line is 1 unit above the x-axis, so we call it y equals 1. Anywhere I go on this line, the y coordinate is going to be equal to 1. Reflecting over a line like this, y equals 1, is exactly the same as reflecting over the x-axis. I'm just going to count how many spaces it takes me to get there. 1, 2, 3. And then I'll go 3 more. And I'll have my new point, Q double prime. I'm sorry, Q prime. That's it. Same thing as reflecting over the x-axis. We do another one. This is y equals -3. The line's located 3 units below the x-axis. Anywhere on this line, the y value is going to be -3. I want to reflect over that line, so I count 1 unit till I get to that line of reflection. So 1 unit more gives me p prime. I can do the same thing for vertical lines. Vertical lines have the form x equals, and it's how far to the right or to the left is this line from the y-axis. So if I count 1 unit in the x direction, I end up on this line. The x value for any point on this line is going to be 1, and we call it x equals 1. If I want to graph my new point, I count to that line of reflection, 1, 2, 3, 4. So I have to go 4 more, 1, 2, 3, 4, and that would be my q prime. It's important to note that if for some reason a point that we're trying to reflect ends up directly on the line of reflection, like this green point right here, it's sort of like if you do touch your fingertip to a mirror, you're not going to see you're not going to see the reflection of your fingertip. And so if I were to reflect a point on the line of reflection, it would just stay in the same spot. And we could do one more. This line is 2 units to the left of the y-axis, so we call it x equals -2. I'm going to count 1, 2 units to the line of reflection, so 1, 2 more units gives me p prime. Maybe the trickiest of all of them is reflecting across a line y equals x or y equals -x. Oops. So first it's important to know y equals x is this line that has the slope of 1. So, and it goes through the origin of the coordinate plane. So slope is 1 over 1, 1 over 1, up 1 over 1. That's the slope, or the line y equals x. If I want to reflect in this line, I still can count to the line, but now I'm sort of counting these spaces. So to get from Q diagonally to this line, I have to count through 1 block and then through a half a block. And so that means I need to go the same distance in the other direction. So I go down a half a block and down 1 more block, and there is Q prime. It should look, if I folded this coordinate plane over this axis, it should look like Q would end up on Q prime. I know my Q prime isn't a very good dot or point, but they should land right on top of each other. So again, we're counting spaces this time through the space diagonally. So 1 and a half, so I go a half and then 1. And if I were to connect these 2 points, what I would end up with is a line that's perpendicular to my line of reflection. So let's do another one. I'll make sure I make a nice point this time. I want to reflect P over this line y equals x, so I'm going to count diagonally through the space, 1, 2, so I need to go 2 more, 1, 2. And it should look like if I folded over this line, P would end up on this point. The line y equals -x, hopefully you notice, goes the opposite direction. It still goes to the origin, but now we're going down 1 over 1, down 1 over 1. It has a negative slope. That's why there's a negative in front of the x. We're going to plot our point the same way, or find our reflected point the same way. We're going to count through diagonally these spaces. So I would count 1, 2, until I got to the line of reflection, and I need to count 1, 2 more to get Q prime. Again, these things should look like symmetric pictures. It should look on one side like it does on the other. I've got one more. I want to count 1 and a half, and a half, and 1. So reflecting points is just like counting spaces. Each point has to be the same distance from the line of reflection as its image has to be from the line of reflection on the other side, just like looking into a mirror. I will do some practice in class. If you have any questions, make sure you're ready to ask.